We've shown how top-down design can be used to add adaptive features to components that already exist in an assembly. You can also use top-down design to create components that are entirely new. This stapler still needs the part that slides along the staple holder and pushes the staples to the front. Since there isn't a lot of clearance between the parts, it'll be a lot faster to create the part in the assembly rather than creating it separately and then making changes so it fits properly. In addition to creating the part, I'll also show you some modeling techniques that make the design more robust. I'm only working with the staple holder components, so the first step is to create a view rep that hides everything else. I'll press the Shift key and select all of the components in the browser. Then, I'll press the Control key and click on the staple holder components. I'll click the Create icon on the ribbon, which opens the Create in Place component dialog. This dialog has several fields for the data that defines a new component. First, I'll change the name to Staple Positioner. I'll leave standard.ipt as the template, although I could create a subassembly if I wanted. We want the new part in the same folder as our assembly, so I'll confirm the file location is correct. I'll leave the other settings at the defaults. Then I'll click OK. The new component glyph is attached to the cursor. I want to place the new part on the inside face of the staple holder, so I'll switch to the back view. Zoom in and select the face. Notice that the new part is added to the browser, and the sketch is active. Before I sketch anything, let's return to the assembly so we can position the part. I use the origin geometry to position parts whenever possible, so my first step is to turn the staple positioner origin geometry on. As you'll see later, I can take advantage of the origin geometry when I'm modeling. The primary function of the staple positioner is to push the staples along the staple guide. When I created the part, a flush mate was automatically added between the XY plane and the inside face of the staple holder. Next, I'll constrain the XZ plane to the top of the staple guide. Since the staple positioner needs to be aligned with the center of the staple holder, I'll select the YZ planes in both components. Using the origin geometry has a couple of advantages. It is easier to constrain the staple positioner in other assemblies when I can select the origin plane instead of model geometry. I can also use the origin geometry during modeling. Before we start modeling, I want to make some view changes. I'll turn the top part back on. Then I'll switch to the View tab and start the half-section view command. Then I'll click on the front face of the staple holder and drag the cutting plane back. I want to look at the parts from the back side, so I'll switch the direction and finish the command. I'll switch to the back view and zoom in. And I have a good view inside of the staple holder now. I'll edit the sketch again so we can start modeling. Since I use the origin geometry for the assembly constraints, I'll project the X and Y axes into the sketch. I don't have to project the edges of the staple guide since I know how big the staples are. I'll sketch a couple of rectangles to get the basic shape. Next, I'll add coincident constraints between the midpoints of the top rectangle edges and the Y-axis. I'll add dimensions for the thickness of the rectangle, the height of the rectangle, and the inside width. One advantage of working in the assembly is that I can do a visual check to make sure that the parts won't interfere. You can see that there's some interference in this corner, so I'll edit the thickness dimension. Then I'll switch to the Model tab. Start Extrude, and select the rectangles. I'll go to the Home view and click OK.